In the region of the germinal center called light zone, the B cells are positively selected based on the affinity for the antigen. More precisely, the B cells bind and extract the conjugate from the follicular dendritic cells, and after the processing, they present peptides from the protein carrier to the T follicular helper cells that provide survival and proliferation signals thanks to cytokine and cell-cell interaction. After the activation, the B cells migrate in the black region of the germinal center where they proliferate and express the cytidine deaminase that increases this mutation rate, introducing small mutation in the antigen binding site of the BCR. After that, the B cells migrate again in the white region where they are selected. The iterative cycle of this process allows the affinity maturation and the isotopic switch of the B cells that at a certain point will go outside the lymph node to sustain the immune response. Before reaching the actual formulation of the glycoconjugate vaccine, different strategies were performed to find a correlation between the germinal center reaction and the immunization obtained in the patient. A first strategy was the co-delivery of the polysaccharide together with the protein of the carrier, not covalently linked, but in this case the B cell wasn't able to take the whole complex, and for this reason the interaction with the T follicular helper was impaired. A second case in the immunization of a patient that already possesses free antibodies for the specific antigen. In this case, there is a competitive binding between the free antibodies and B cells that produce a reduced activation of B cells. This aspect is specifically important to determine the time needed before a second injection of the antigens, since the free antibodies generated during the first immunization can be present also after 3 months from the first injection. A common strategy to overcome this issue is to increase the dose, but this also increases the risk of side effects.